Hi guys, it's Mrs. Millicent. Let's do the check your understanding on page 194. Okay, in section 3.1, you read about the Old Faithful geyser in Yellowstone National Park. The computer output shows the results of a regression of y, which is the interval of time until the next eruption in minutes, and x, which is the duration of the most recent eruption in minutes, for each eruption of Old Faithful in a particular month. Okay, so it looks like we're using duration of the eruption to predict the interval or the time until the next interruption. Okay, so we have this lovely computer printout. So we need to glean some stuff from this. So the first one is, what is the equation of the least squared regression line that models the relationship between interval and duration? Define any variables. That means our x and our y. So we come down here, and it says intercept. So there's my y-intercept, okay? And there's my x or explanatory variable, which is the duration of the most recent interruption. So that's my slope, okay? So my least squared regression line is y hat equals 33.347442 plus 13.285406x, okay? So this will always say intercept or constant or something, okay? And the number opposite it is the y-intercept, or the b, and then, or not the b, the a in this case, a plus bx, and then the item underneath it will always be your explanatory variable. This will always be your x variable, and then this is your corresponding slope, okay? So let's label. So x is duration of eruption in minutes, and then y is the predicted interval or predicted, I'm going to say time to next eruption, also in minutes. Okay, so that's how I glean my least squared regression line from my computer printout, and you'll probably see a lot of these on the AP test. Okay, so we write the equation of least squared regression line, we define any variables, we're good to go. Okay, interpret the slope. Here we go, interpret the slope. So what does this mean? For each additional minute that the eruption lasts, we predict the time to the next eruption will increase by about 13 minutes. Okay, so for each additional minute an eruption lasts, we predict the time to the next interruption eruption to increase, since it's positive, by, I'm going to say, about 13.29 minutes. I'm going to round that, okay? So that is my interpretation of slope, okay? So again, for each additional x, I predict the y to either increase or decrease by the slope amount. Okay. Next question says, identify and interpret the standard deviation of the residuals. So standard deviation of the residuals. Okay. So that is usually my prediction error. That's how much my predictions are going to be off. So that's up here. Root mean square error. So it's 6.49. I'll say 3357. Okay. So what does that mean? So standard deviation of the residuals. Remember what the residual is. The residual is the distance between the actual and the predicted. So this simply means when I use this prediction, when I use this least squared regression line to predict the time until the next eruption from the duration of the eruption, my predictions are typically off by about 6.5 minutes, okay, on average. So that's my interpretation of standard deviation residuals. I'm going to move the book so it's easier to read and write this. Okay, this is a long sentence. So when using the least squared regression line, I'm going to abbreviate LSRL. When using the least squared regression line to predict the time to the next eruption, from the duration of the eruption, my predictions are typically off by about 6.5 minutes on average. Typically off by about 6.5 minutes on average. Okay? So again, standard deviation of residuals. When using the least squared regression line to predict the y from the x, my predictions are typically off by about the standard deviation of the residuals minutes on average. And this unit is always the unit of the y because that's what I'm predicting. Okay? Okay. I'm trying to think. 6.5 minutes, that seems kind of, I don't know, that seems kind of long, but I guess when you're standing around Old Faithful, what's 6.5 minutes? You're just enjoying the view. Okay, let's look at I think there's one more, right? What's it say? What percent of the variability in interval is accounted for by the least squared regression line with x equals duration? Okay, so anytime you see percent of variability or percent of variation, they're talking about the coefficient of determination or the r squared. Or the r squared. Okay, and what r squared tells us, it's a kind of way to quantify how tight the observations are to the least squared regression line. Okay, so let's look at our computer printout. R squared, r squared, r squared. I see r squared and I see r squared adjusted. Don't use adjusted. Use the r squared. So in this case, it's going to be 0.853725. Okay, so it's about 85%, 85.4% of the variation in the time to the next eruption is explained by the least squared regression line that relates the time to the next interruption from the duration of the eruption. Okay, so anytime you see this percent of variation or percent of variability, they're talking about the r squared. Okay, so I think it said what percent, so my answer is about 85.4%. Okay, and I think that's it for that one. All right, I hope that was helpful, and I shall see you next time.